Okay, derivatives of logarithmic functions. Well, I mean, we're only a few months into derivatives, and logs are kind of confusing, so today we start to get, we're putting multiple things together that I feel like everything before now has been fairly straightforward. Not easy, but straightforward. Now we're doing like hard stuff upon hard stuff, derivatives of logs. So we are going to take a few minutes to talk about logs. You don't need to know this vocabulary here, but logs and sines are transcendental functions, not algebra functions. Whatever. Let's talk about some log properties. So let's review logs before we talk about derivatives of logs. Natural log x is the log base. It's like what's the invisible base that's right there for a natural log? It's not 10, although there is one that's 10. It's e. 10 is if it's not written at all. Like log of 100, that's base 10. That's the missing base right there is 10. The missing base on natural log is e. Remember what the natural log of e is? Even if you don't remember, you do the little loop-de-loop thing. This means e to something, e to the something equals e. So what's that exponent have to be for this to work? 1. E to the first is e. That means the natural log of e is 1. Natural log of 1, that means e to something is equal to 1. So what's got to be in the box over here? 0. E to the 0 is 1. Definitely got to know those. Right? Properties of logs. You remember how you can split up natural log of x plus y? How to expand that is the fancy way to say it. Oh man, hope you remember it once you see it here. Natural log of x plus natural log of y, does that look familiar? Okay. Because we're going to do that a lot today. How about natural log of x over y? Yep, natural log of x minus natural log y. I'll give away the game here. The reason we're going to expand is because taking derivative of expanded is a whole lot easier than taking a derivative of this way would require the quotient rule. But if we expand it, we don't have to worry about the quotient rule. So a lot of times with logs, we'll expand first, we'll algebra first, and then take derivatives. Do you remember where else this a can go? Go up as the exponent. And so another one where we'll a lot of times put the a down front to make the derivative easier. Let's see. These next two questions kind of go together, and depending on how you think about natural log, probably influences which one you do first. I like getting domains from graphs, so I'm going to graph it first. Let's see, natural log of 1 is 0. And the natural log of e is 1. E is like 2.7 something. And I don't know, but you need to have, that needs to be in your brain library of what graphs look like, is natural log of x. So now I'm going to work backwards a little bit. What's the domain of this graph? What are the x values that are covered? 0 to infinity. If we're going to talk interval notation, you could just say x is greater than 0. You can't take the log of 0. You can't take the log of a negative number. So it has to be a positive number that you take the log of. Right, these next three questions should be easy now that we have the picture. Dangerous to say something should be easy and then pull a popsicle stick. But Ryan and Zach and Alec, they know what they're doing. Ryan, how about the limit as x approaches 0 from the right?
Wouldn't that just be 0?
As x approaches 0 from the right, yeah, thankfully from the right because there is no from the left. So what are we doing? Negative infinity. We're headed toward negative infinity. Zach, what happens as x approaches infinity, as x goes way, way out there? What's the graph doing? I would accept that. Why doesn't it exist? That's a great explanation. It's getting bigger and bigger, which means it doesn't exist. So D and E is the technically correct answer. But why this is on there is to remind us that it gets bigger and bigger. Very slowly. Right? It's not shooting up, but it is getting bigger. Alec, that graph has a vertical asymptote of x equals 0. Okay, so none of that was calculus. So that was all pre-cal algebra stuff that you hadn't seen in a long time. But remembering that will help us when we start doing derivatives. Okay, this next chunk of stuff is a way to figure out for ourselves what the derivative is. But I don't want to get the calculators out. It takes too long to simply discover that the derivative of natural log of x. Hey, we've finally gotten past what y'all covered in pre-cal last year, right? Finally teaching you new stuff. Derivative of natural log of x is 1 over x. U just means it's something other than x in there. So we kind of know this one already, but this is going to use the chain rule. 1 over u times u prime, because that's the chain rule. That u prime is a result of the chain rule. And then I frequently write it like this because I'm thinking chain rule, so the rule is 1 over the argument times the chain rule. Some people will sort of memorize the chain rule thrown in together and write it like that. Those are obviously the same thing, but writing it like this kind of emphasizes the chain rule. This sort of sandwiches it together. Either way is fine. Those will be on a note card tomorrow. 100%. In fact, I'm going to do it right now so that I don't forget. Take the derivative of 1 over x. So, whoops, that's not right. That's the answer. Let's take the derivative of natural log of x. There we go. Add that one to the pile for tomorrow. Okay, that's it for the new stuff. We're going to do some practice problems. We're going to use it. We're going to whatever. But that's it for today. You've got to know the derivative of natural log is. Actually, that's not quite it. We're going to do one more thing. Derivative of natural log is 1 over x. Now, here's the one other thing. If the base is not e, let's do the algebra way, and then we'll just talk about the answer here in a minute. Another property of log. This is called the change of base formula. I don't know that you do this in pre-cal. But another way to write log base b of x is natural log of x over natural log of b. That's a log property that I don't think we use in pre-cal. So that means the derivative of log base b of x, it's like, well, hold on a minute, I don't want to do the derivative of log base b of x. I want to change log base b of x into 1 over natural log b times natural log of x. So I'm just algebra step. Because 1 over natural log b, that's just a number. I don't know what that number is, but it's just a number. So 1 over natural log b times 1 over x. Okay, so let's fill in this box. Some of this box we know, some of it not so much yet. That's okay. Harper, how about that first one? That's the card that somebody's going to get tomorrow. What's the derivative of the natural log of x? 1 over x. That's the easy one, or the easiest of the bunch anyway. All right, if it's a u in there, it's 1 over u, but then chain rule times u prime. If the base isn't b, then we need 1 over natural log b out front times 1 over x. And this last one, that's the same one. That should be a u. That's why that doesn't look right. Put a u there. So it's going to look similar to that previous one. Still 1 over natural log b. And then the derivative of logs is 1 over u. And then the chain rule is u prime. Can't see my prime very well. Now, if you wanted to simplify things, this one, it's the least simplified, but that's the most generic one. That would work for everything. Like if the base was e, natural log e is 1, that part would go away. So if you memorize this one, you'll automatically catch everything. Most people, when it comes to memorizing, they'll know this one because that's the easiest one. They'll know chain rule, and then if the base isn't b, you got to have an extra term out front. All right, let's do some together. Examples. Find the instantaneous rate of change. Again, with the constant mixing up the vocabulary here, just to make sure we're on our toes. Lexi, what's instantaneous rate of change mean? Find the derivative. So we want the derivative of this thing. So the derivative of a log is 1 over the argument, and then chain rule times the derivative of the argument, 6x minus 4. Thank you, sir. Again, that's how my brain thinks of it, because it's 1 over the argument times the derivative of the argument. Many of you are going to sort of squish the chain rule in with the regular rule and just write it like this from the get-go. And it does look cleaner to write it that way. It's just not how my brain thinks of it. Oh, why am I not done with that problem? Yep, when x equals 2. So I haven't used this much, but that evaluate bar, if you put a line and then x equals 2, that means I'm about to plug in 2, or plug in 2 and see what happens. So 6 times 2 minus 4 over 3 times 2 squared minus 4 times 2 minus 1. Safe stop. But 12 minus 4 is 8. 12 minus 8 minus 1 is 3. So 8/3 on the multiple choice section of the test. All of that on the safe stop free response part of the test. Number 2. If g of x equals natural log of the cube root of x cubed minus 3x, find the slope of the line tangent to the graph. Sophia, if I want the slope of the line tangent to the graph, what am I looking for? The derivative. Again, we're just making sure we know these vocabulary words. Okay, this is going to be a really ugly derivative if I take it right now. But if instead I do a little algebra work on this thing, right, are you with us? Okay. I can rewrite the cube root as power of 1/3. And why would I do that? Like, what can I do with that 1/3 now? Yeah, I'm going to bring it out front. Otherwise, I'm going to have this massive chain rule issue on my hands. So algebra first on these, if possible. Still haven't done any calculus. That's still algebra. So do algebra first when you can. It will make life a little easier. Okay, so the derivative, the 1/3, that's a constant, so that's just kind of going along for the ride. And then the derivative of natural log is 1 over the argument. And then the chain rule is the derivative of the argument. We'll put some people on the spot here. Caden, what's the derivative of x cubed minus 3x? Good. That's kind of spread out and unruly of an answer if it's a perfectly okay answer. But I also see that both of those are divisible by 3. So if I wanted to clean this up, x squared minus 1 over x cubed minus 3x. And again, the difference between a multiple choice answer and a safe stop answer. Nothing wrong with this answer, but on the multiple choice test, it's going to be cleaned up to look like that. Yes, sir.
So with natural log, when you move the exponent of 1/3 to the front, you don't subtract 1?
No, because this is not calculus. This is all algebra. Okay. Now you're right. If you take a derivative of this, move the 1/3 out front, subtract by 1. But that's taking a derivative. What we're doing is just using a property of logs. So yeah, that's a good connection there. I hadn't thought about that before. Because you're right. In calculus, usually if you bring the 1/3 down front, you're decreasing that by 1. But that's for taking a derivative. This isn't a derivative, this is algebra. That's a good question. Let's see. In terms of x, meaning I don't have to plug in anything, so we're done with that one. Number 3. H equals this. H prime would be some ugly quotient rule thing, because I'd have to do 1 over all of this, and then I'd have to use the quotient rule, and so I'd have a really ugly. Instead, though, let's do some algebra. So algebra first when you can. I can split this up with subtraction. So natural log of 2x minus natural log of x minus 3. I've not done calculus yet, right? That's just algebra, but it's going to make my calculus much easier. This is also why I try to emphasize you label your work so I know what you're doing. If you start writing stuff down, I can't follow when you actually took a derivative. Okay, so 2x in the bottom. What goes in the top? Yeah, just 2. That's a cleanup situation in a moment. 1 over x minus 3. Derivative of x minus 3 is just 1, so we're good on that one. I'm going to reduce those 2's. So 1 over x minus 1 over x minus 3. Wait, how did I switch to a minus here? Yeah, that should be x plus 3. Fortunately, it didn't change anything else. I contend this answer is right, but why isn't it one of my answer choices? Like, how do I get from here to answer choices? Algebra all-stars. What does it take to add fractions? Common denominator. So this one needs an x plus 3. This one needs an x. So x plus 3 minus x over x times x plus 3. Let's see, the x's will cancel. I'm left with 3 over x times x plus 3. There we go. So that problem was algebra step, calculus step, then algebra step again. Emma? Because, let's see, the derivative of natural log is 1 over the argument, but that top 2 is a chain rule thing, because the derivative of 2x is 2. Oh, natural log of the absolute value of secant of x? I don't think there's any algebra I can do. I don't know if that simplifies anyway. So let's see, 1 over the argument. So 1 over secant of x times the derivative of the argument, so times the derivative of secant. A few people had that on the way in. I don't know if Claire was one of them, but Claire, what's the derivative of secant of x? Why is that not one of my answer choices? The secants will cancel. Braden? Okay. It's a good question. You can't take the log of anything negative, so that's why they put the absolute value on there to make this doable. But the question then is, well, does that affect the derivative? And it doesn't. But it's a good question. Uh-oh, what makes 5 different than the previous ones? Base 7. So I'll need to think about that base 7. Hey, what about this 5? Can I bring this 5 out front? Why not? It's only on the x, it's not on the 3. If it was 3x parentheses to the 5th, then I could bring the 5 out front. Alright, so f prime. 2's there. How do I handle the fact that this is base 7? Flip back, keep it looking back. Let's see. So there's my base that's not e. So 1 over natural log 7 is where the 7 goes. And then the derivative of natural log is 1 over 3x to the 5th. And then, Laura, what's the chain rule? What goes in the top here?
15x to the 4th.
Good. So there's another one that's perfectly acceptable as a free response answer, but as a multiple choice answer, let's see. Definitely going to have natural log 7 in the bottom. 2 times 15 over 3 is 10. And then there's an x in the bottom. So algebra there. And that might even be changed to look like that. That might be the best or simplest answer. Again, nothing wrong with this. That's a safe stop. But multiple choice usually cleans things up a little bit. Number 6. What are we going to have to do in number 6? (3x) times log base 5 of x squared plus 7. What rule am I going to need for that one? Yeah, product rule. I added product and quotient rules to the list of, in here somewhere, to the growing number of cards. There it is. You knew that one already. FG prime plus GF prime. So I'm gonna attach the 3 to the x, call that F, call that one G. Do I want to write out the pieces, or do I want to just like jump in and do it all at once? Product rule on the fly. Let's do product rule on the fly. We're good. We can do this. So let's do the derivative of the first one first, just because that's the easy one. Which means we'll leave g alone, so that's still just log base 5 of x squared plus 7. Plus, now I need to do the derivative of f. That's easy. No, not the derivative of f. I need to leave f alone, so 3x. That's what I get for not slowing things down. So fg prime f prime g plus f g prime. That's what happens when I product rule on the fly. I should have at least labeled the pieces. Okay, so now the derivative of the log part. It's base 5, so that means I need the 1 over natural log 5 out front to handle the 5. The derivative of the natural log of something, or the log of something, puts x squared plus 7 in the bottom. Heck, there, I've only got the chain rule left. What goes in the top?
The 2x plus 7. 2x.
Good. Just the 2x. And I'm thinking that's about it. Like, I don't know that there's a whole lot more we could do. 3 log base 5 x squared plus 7. Certainly not on that part. Oh, I guess on these part, 3x times 2x is 6x squared. So 6x squared over x squared plus 7 times natural log of 5. Cleaned it up just a little bit. those are equivalent answers, which means they're both okay. But again, we like to clean it up for the multiple choice. So, man, number 7. What do you want to do first on number 7? Because I really don't want to take the derivative of all that. Is there something I could do that would make my life easier? Yeah, split it all up. So 3 natural log of x plus, I'm going to skip a step because I'm short on space. What's the square root as an exponent? 1/2. So I'm going to rethink this square root as a power of 1/2 and then move it out front. Oh, still need a 3 there though. Natural log of x squared minus 3. And then minus, because cosine's in the bottom, natural log of the cosine of x.
Why do you do 3 on top?
Yeah. Yep, I need a 3 right there.
Also, why do you do the 3 halves? Like the 3 on top?
Because it was 3 times 1/2.
Okay.
Alright. Have I done any calculus yet? No, all that was algebra. But it's going to make my calculus a lot easier because instead I was going to have to do product rule combined with quotient rule and chain rule. Now it's just chain rule. So I'm going to press pause, and why don't you try to finish this problem? So, derivative of natural log is 1 over x. 1 over x squared minus 3 times the chain rule. 1 over cosine times the chain rule. A little bit of cleanup work. What about sine over cosine? That's tangent. And again, nothing wrong with the first answer. But especially that tangent thing, that would definitely be something you have to be careful about when you're looking for your multiple choice answer. Marie? So, let's see. So the 3/2 is out front. So you're okay with this, right? All I saw was that I could cancel those 2's, and that would just leave the 3 in the top. It's all right. One more. What do you want to do first on number 8? Separate those. Natural log of g of x minus natural log of f of x. That's not calculus, but it's going to make my calculus a lot easier. Ooh. So how do I do the derivative of the natural log of g of x? Yep, g of x in the bottom, the derivative in the top. F of x in the bottom, the derivative in the top. And then all of that at x equals 1. Okay, here, so there's g. There's f. This is the blue stuff, g is the green stuff. This is me just trying to keep track of things. So g prime, that's the slope of the green line. That's negative 1/2. G of x is the y value. That would be 1.5. I'm going to rewrite that as 3/2 so I can do a keep it, change it, flip it here in a minute. Minus f prime at 1. Oh, that's negative 1. And then f of x at 1, the y value at 1, is 6. Slopes and y values. And now I've got an algebra problem to deal with. So negative 1/2 times 2/3 would be negative 1/3. So negative 1/3 plus 1/6 would be negative 2/6 plus 1/6 is negative 1/6. It was a little bit of calculus, a whole lot of algebra. Stamp go. That one deserves the stamp. Because it took algebra to start and it took a lot of algebra at the end. The actual calculus wasn't that bad. Today's assignment is the next worksheet, worksheet 2. Again, please keep up with this stuff as we go. It makes life easier when you get toward the end.